Before we move on, just here in part two, just a quick note. I want to follow up on this idea of function versus not function because the mapping itself does show you clear violations of like the function definition, like this one input to one output. But it might be a little hard to pick out because there are so many kind of lines and arrows. So one thing I can suggest as like another tactic is to actually graph these things. So if you take them to be x and y values and you start to graph these values, let's go to this. Oh, okay. 2, 4 will be approximately what, about right there. 3, 5 then is there. I'm sorry, 3, 8. 3, 8 should be way up here. 4, 8 should be right next to it. And then 5, 5 should be right here. And so if you look at that and consider that like as a curve or as like a connected lines or a connected graph, you can see that it also doesn't violate the function part for the graphs either. Like the whole one input, one output, that's often characterized as a vertical line test. Whereas if you look at this one over on this side and try to do the same thing, okay, 4, 2 is about right there. We have 5, 2, which is right next to it. Then we have 5, 9, which is up here. 8, 5, yeah, 8, 5, somewhere in there. And then you try to connect these with the same kind of logic, the same kind of curving. We actually have a direct vertical line right there, which again, by this idea of what a function, it means to be a function using a graph. Okay? So it's more than one way to tell it's a function. Let's go to some review of stuff we started the year with. Find the center and radius of a circle whose equation is given as the following. And so this is good review. We're going to use similar tactics as we did to find roots, which is we're going to take all our variably defined values, and put them on one side of the equation, which means we just can't move them. We actually have to add them. So that's going to be plus 3x. So this is going to be plus y squared. And then if we subtract 14y from both sides, that'll be minus 14y, and that's going to equal negative 1. Okay? So we're trying to find the center and radius, which means we have to convert this to standard circle form. So we're going to complete the square a couple times. So first we'll complete the square in the x's. So this will be, you'll see, x cutting plus 3.5 will be plus 1.5, and that'll be squared. So now we have to take 1.5 squared and add it to the right. 1.5 squared is 2.25, and so we'll add it to the right, because that's what completes our square. Then we'll complete the square here. And so y minus 14 will actually just be y minus 7 squared. 7 squared is 49. Several people were adding that together, which is a little disturbing because remember it's going to be a squared term. That's multiplication, so that's plus 49. So do a little cleanup here. We have x plus 1.5 squared plus y minus 7 squared. 49 plus minus 1 is 48. Plus 2 would be 50, so we have 50.25. Now, do recall this is just a Pythagorean theorem, a squared plus b squared equals c squared. So this is actually a squared term. That's our radius squared. So if we want to extract our center, it's going to be our values here. So it'll be negative 1.5, because remember the formula for a circle is x minus h squared plus y minus k squared equals r squared, which means the h value must be subtracted. Since we see a positive sign, that means our value is going to be negative. Our k is just going to be 7. And our radius is just going to be the square root of 50.25. You can type that into a calculator if you'd like. It's not necessary for this problem because the big idea here is being able to complete the square to the formula. And as soon as you have this formula, you're more or less have completed the task. Now you just have to extract the right information. Distance formula. Okay, so the form of distance formula I think I've been using this whole time and I'm going to continue to use is that the distance is equal to the square root of the change in x squared plus the change in y squared. Now remember, this is no different than looking at the formula in full form. The x1 minus x2 squared plus the y1 minus y2 squared. I'm just acknowledging that when you subtract your x's, you're just telling me how far apart x's are, and when you subtract your y's, you're just telling me how far apart y's are. And so we can just skip forward and just do that counting in our head even. And so if we're going to find the distance, you could plug in the formula, but we can also just ask ourselves how far apart are negative 10 and negative 15. They're 5 apart, so that turns into 5 squared. And how far apart are y1 and y2? 2 and 14. Well, 2 and 14 are 12 apart, so that should be 12 squared. Now, plugging into the formula, you should get the same values. You should end up 5 squared and 12 squared. Although the negative 5, it could be negative 5, it could be negative 12. But when we square it, it's not going to matter after that step anyway. So the distance in this case is equal to 25 plus 144, which is the same as 169, which is a perfect square of 13. And so the distance in this case equals 13. All right, last two, ACT prep. So more number work here. If 1 plus square root of an under square root negative 5 squared, we want the actual value for that. And so this is probably going to require us just to actually work it out. So here's where we're going to have to really remember our order of operations, what comes first, what comes second, what comes third. So please excuse my dear Aunt Sally is going to guide her work here, which means parentheses go first. I just have a negative 5, then come our exponents. And so under the square root, I'll still carry this one negative. But if I take negative 5 and then square it, I should end up with 25 as a positive value. Now let's do our multiplication division. So 1 plus the square root of negative 25. Now, we've dealt with this before. Now that we have some knowledge of complex roots, we know square root of 25 will break down in square root of 25 times the square root of negative 1. And so square root of 25 is just 5, square root of negative 1 is I, and so we should have 1 plus 5i, and look at that, we have our value right there. So the control in this was actually, please excuse my dear Aunt Sally. Okay. And now let's go and move on to number 8, some more number work. All right, so we have 2 to negative 1/2 to the 4y equals an 8. They want to know what the value of y is. So we could take a couple different tactics here. We could just plug and chug these numbers to find the one we would like. But given the ACT has you timed out at about 1 minute per question, that may not be the best tactic. And so what we probably want to do is just work out as much as we can and simplify this side of the equation using our exponent rules that we've established like way back even in Algebra 1. And then get to a point where maybe we can reason what that value is or maybe directly solve for it. Anyway, let's get to it. Let's see if I can make some sense out of this for you. So we have 2 to the negative 1/2 to the 4y equals 1/8. So I'm going to ignore the 1/8 on the right for now, and I'm just going to focus on this. So please recall that if you have a power raised to a power raised to another power, this is the same thing as having just a to the b times c power. So power to a power, you can multiply your powers together, which means we can multiply 1/2 and 4y together. And so this is actually going to be 1/2 of 4y, which would just be negative 2y. This is good news because now it's going to be, it already looks a whole lot less complicated. I don't think we're quite to the point where we can do some direct solving or logic yet, but at least we're a little closer. The next thing we have to recall is that if you have a base to a negative power, that's the same thing as having, as moving that base to the opposite side of the fraction, so in this case to the bottom, and then making that power positive. That negative does not make your numbers negative. Instead, that negative actually moves your base to a different part of the fraction. And so what's going to happen here is that we'll have 1 over 2 to the negative, to the positive 2y equals an 8. Okay, this is even better news because now we actually have on the right like 1 over a number, and on the left we have 1 over a number, and so we're really, really close. Now the clever observation we can make that's going to finish our work for us is that you can actually write 8 as a power of 2. And so to make these look even closer, I'm going to write this as 2 to the third, and over here I'll keep that as 1 over 2 to the 2y. So the reason this is important is because the fractions almost look identical, except we just have 2y on one side and 3 on the other. But if you acknowledge we have to make them equal, that means 2y has to be equal to 3. And if you take 2y and want to solve for it, we'll divide both by 2, and that'll make y equals 3/2. And so you could have plugged and chugged to find that number. Alternatively, you can use some power rules, and you can get that value 2/3. Right? Guys, so this is part 2 of homework series 1. So that means next time we walk in, you're going to have a quiz that's going to focus on all this homework, which is going to include the stuff we've been doing in class, which will also end our discussion series on roots. And so we're going to move on to actually continuities after this. So I'll see you guys later. Thank you.